All right. Welcome everybody to this webinar. Um, we are having the usual format with about 30 minutes of presentation by David and I, and then followed by up to 15 minutes of Q&A at the end. And don't forget, you can type in any type of comments or questions in the Q&A little tab there as we go. You don't have to wait until the end. So we're going to talk about transition from the old AFFF, which we know has up to 3 to 6% PFAS in it and has created all kinds of environmental problems, to fluorine-free foams, and discuss essentially how do we clean out systems so that when you put the new foam in and you're spraying out a petroleum fire, which is simulated on this picture, how do we know that it's safe? How do we know the foam's going to perform? How do we know the firefighters who think they have fluorine-free foam with no PFAS or very little are safe and protected? So that's the topic of today. And let me introduce David Fleming. Or David, please introduce yourself and tell us just a little bit about you.
Hello, everyone. I am a founder of TRS Group. We started the company 24 years ago to commercialize thermal technology, in situ thermal technology. In the last few years, we've added the perfluoride technology to our business, and it's rapidly growing. I am also lead the business development of our PFAS business. And Gorm, of course, is our Chief Technology Officer. I'm sure you all know who he is. You've attended these webinars before. He's been in the business for, I think we have been in this business, remediation business, for about the same time, 35 plus. I remember meeting Gorm very early on during our careers. Anyway, wonder, Gorm, if you could tell us more about these new fluorine-free foams and how they're replacing the aqueous film forming foams.
I can do that. Let me start by showing a picture of the old stuff that if it's AFFF, aqueous film forming foams, that's been in this case, a tank or the tank of a fire truck for a long time, and maybe it's seen some water that flowed back through a backflow preventer. A lot of times it looks like this when we are out cleaning out a fire system, a truck or a system. You get this orangey AFFF concentrate. And you can imagine how sticky it is inside wherever it is and how tough it is to get out. I sometimes liken it to the DNAPL problem we started looking at 30 years ago. It's like you can pump water from a source zone, but you can't get the DNAPL to come out, right? Similar to this, you can have water run through. It's hard to get all the goo out. What that is being replaced by is the new fluorine-free foam. And I show a little video here of one of those, and you'll see basically how different it is. It's a very short video. Play it again. But essentially, these new foams are a lot less viscous. They're clear, and they're going in the systems after we clean them out. So we're going to be talking today quite a bit about how thorough a cleaning job we need to do before we do that. Let me show you the foams that we know have confirmed are available in the U.S. Solberg, this one up here has been here for almost a year now and approved for use. The BioX comes from Europe and it's made in France, and soon will be produced in Houston as well. And then National Foam is very close to having their approval for the Avio Green and others, a family of fluorine-free foams approved. They still have a final toxicity test that has not been basically approved, the results of that, but it's coming out hopefully in a couple of weeks. Or there's at least 3 foams commercially available to use. So that's not an excuse that we don't have them, and they're even if they're made in Lyon, France, they're actually stocked in Houston, so you can call up and you can get foam. So that's not the holdup. Holdup is really sometimes, do people know how to do it? Do people know how to clean out the old system so that it can safely transition to these new products? So David, with that in mind, would you please tell us a little bit about this perfluoride agent we've heard about, and basically TRS's cleaning out of systems methods, please.
Sure. We're the exclusive licensee of the perfluoride technology from our partner in Europe, Cornelsen. And we became the exclusive licensee for AFFF cleanout using this process a couple of years ago. So it's a plant-based oleic acid. It's biodegradable. And when you add it to water with PFAS in it, as you could see in this little short video here in the middle, the process through a weak ionic bond, when the perfluoride connects to the PFAS, it creates a microfloc, or a small particle that you see floating in the water there. There's a stirring component inside that flask as well. But when that floc has been created in water, so it's a method that uses concentration, sedimentation, and filtration to remove not only PFAS from the inner wetted surface of a tank or a pipe or a gun cannon or a turret, the entire truck we're cleaning out, the entire system, if it's been impacted by AFFF, and then capture that rinsate, use the flocculation process again with perfluoride, and we get this, what you see on the far right there, a substance that's either a dried flocculant or a little bit of a sludge, wet material that's the waste product. One of the big advantages of this process is that we can not only clean out the system that we're trying to perform AFFF cleanout on, but we can also clean the rinsate that we've generated, so that we can get down to, required discharge limits, in some cases non-detect total PFAS, so that that rinsate can be disposed on site and not off site. It saves money, as well as, helps manage liability for our customers. So that's a big advantage of this.
Yep, you may add, so to clean out one truck, you generate how much, 2,000 to 5,000 gallons of
so the ratio, right, 5,000 gallons of water generated, or rinsate generated from cleaning a truck, and producing about 100 gallons or less, a little bit less, of sludge that needs to be.
Okay, what equipment do we use to do all this?
So the equipment, as you'll see in this picture, is this, we call this our mobile batch treatment system. It can be shipped around the country on a 40-foot trailer, truck trailer, as you see here. And the equipment that you see in the middle there, we call that our mixing tank. It's a stainless steel mixing tank that has a heating component to it. It can handle about 900 gallons of water. And we're also building a new system that's almost twice the size of that tank, that is almost ready for delivery. And then if you move to the left of the mixing tank, you can see the cone-shaped sedimentation tanks, those white big sedimentation tanks. And then between the mixing tank and the sedimentation tanks is our filtration skid, with a bag filter on the front end of it, and then a couple of liquid carbon vessels for polishing rinsate. And then off to the right of the mixing tank are some ancillary pieces of equipment, electrical components, and storage tank, and etc. But point is, this is mobile and shipped anywhere in the country, U.S.
Mm-hmm. Cool. And we have a little video that helps explain. And
exactly. So here's an actual in the field video. It's about a little over a minute long. First, what we're doing, Steve Pistol here is our field service manager. He is mixing the perfluoride in a heated 5-gallon bucket. So we're heating it up to lower the viscosity of the material. He's homogenizing it. Once he gets it mixed up thoroughly with that stirrer, he'll take a sample of it, 100 milliliters, really not very much, and go over to the mixing tank, pour it in there. And he's creating the solution that'll ultimately get flushed through the truck in this case. And you can see just a slight color change in the water there. The water is heated. So you've got the perfluoride heated water mixture that's then flushed through the truck in this case multiple times, could be 3 to 5 times, using the truck's venturi, the pumps, our pumps perhaps. And then once that rinsate is created, it comes back into the tank, as you see here. And then we continue the flocculation process. There's foam formation you see on the surface there. That's a visual indicator when there's no more foam formation that we're clean. And then he's cleaning the tank here. You see the AFFF tank with the solution. There's an agitation process as well. This is the sedimentation tanks. And then you see the through gravity separation, the final product here, which is the floc and perfluoride PFAS sludge that's disposed off site.
All right. Good job navigating it. Can you just for everybody's benefit, how much have we actually done of this kind of work?
So we have, in combination with Cornelison, they've been doing this in Europe for since 2015. We started doing it a couple of years ago, but we have done combined 189 ARF and structural truck cleanouts. Smaller amount in the US, larger amount in Europe. And then for fixed systems, you see there in the middle, airplane hangars, other building sprinkler systems, combined again, 51 stationary systems. Again, the majority of those in Europe. We've done some here in the United States. And then off to the far right, in terms of treating water impacted by PFAS with the perfluoride process, more than 126 million gallons have been treated using this process, again, most of which has been performed in Europe.
So that's not a typo, 126 million
gallons.
Not 1,000 gallons, it's million gallons.
Million gallons, a lot. So point being, this process is market available, got a lot of history, a lot of experience, a lot of results. So it's very well been used around, in the United States and in Europe.
All right. So what's the government recommendation for transitioning to foams? Is there one, and what does it say?
Well, so if you consider the FAA cert alert that came out, the first one came out this past spring, April 24. They had basically provided some guidance for doing AFFF cleanout and saying that one single rinse using potable water, not heated, was sufficient. And they called it at that time best technology. Well, there was quite a bit of pushback from the industry once that cert alert came out and that reference was made, the best technology. And so then they reissued the cert alert in May of 24, just last month, saying basically that they removed the reference to best technology, and they still are saying that one single potable rinse of water is sufficient, which we don't believe that it is. And in fact, what we're doing with perfluoride, and there are other companies that have similar, more aggressive solutions, than just water alone, is our best technologies out in the marketplace. And we're hearing that resonate with the marketplace as well, with the industry.
Sounds almost like 40 years ago, people said they could clean up DNAPL source areas with pump and treat, right? Do it for a year and then you can turn the system off. But we realized that's not enough. You can leave a separate phase in there. The phase transition is just not going to be fast enough.
So that's a good point, because one element of this is that we are physically providing cleaning in addition to the solution that's being flushed through the system. There is agitation, there is scrubbing in some cases, there is pressure washing, there is another element that it takes to get these systems clean. And with water alone, that's not sufficient.
Mm-hmm. Maybe I can explain a little bit about this.
Yes,
John,
please.
Yeah, John C. and others have published this paper, just one of many, but basically showing how PFAS residues from AFFF will make these layers on almost everything that these chemicals flowed through over time, inside the tanks, inside the pipes, inside the venturis probably as well. So the whole belly of the fire truck, as I like to call it, you can assume it has some of this stuff, and it's really hard to get off. Definitely with water, we are seeing pictures before and after water flush. They look almost the same as if this surface hasn't even been touched by a water flush. So another indication of why the flushing with water, in our opinion, is not sufficient. This is a stainless steel tank that we did not just one water flush, but 3 successive water flushes. So what was also called triple rinse on. Looked quite good. We got all the little goo out. There's no yellow stuff in here. But then we did a test and pressure washed it, or basically took a pressure washer and sprayed the surfaces and the little crevices and stuff. And this is what it looks like. So this is basically PFAS foam residue that's invisible to the eye when you've just done any type of water rinse, but absolutely is there. And if you sample this, it's screaming rich in PFAS. So this is, if you just follow the CERT alert and do the absolute minimum, you can assume that water or new foam that goes into these systems will have lots of PFAS. And that's, in our opinion, a problem. Another way we looked at this was we took a whole fire truck and we did a triple water rinse first. So like 3 times the recommendation. And then we followed it with a warm perfluoride rinse. So we did first, what's recommended times 3, and then we ran our perfluoride through. And this is what came out of that fire truck. This was done in Connecticut. So after it was supposed to have been clean and we run our warm agent through, we get all this additional stuff liberated from the belly of the truck. Another indication that it's not just those tanks that you're looking at, the beautiful tank I just showed, it's also the inside of the pipes, venturis, distributors, hoses, everything gets flushed with this warm rinsing agent, and it releases a lot more PFAS than you do with water, particularly if you're just flushing the tank of the truck and not the whole belly of the truck and all the internal pipes. So what does that mean if you don't clean it out properly? What's going to happen afterwards? We can look at what we call the rinse, the final rinse. So you do whatever cleaning you're doing, and then you run water through the truck and you sample that water. If you have before you clean it out, even with water, here's the PFOA levels we measured in the water running through the unclean truck, like 1,300 nanograms per liter. It did okay, like 90% reduction, maybe, or 80% reduction by rinsing with water, but still quite high concentrations. And then we did the perfluoride and then stopped that and did clean water, ran it through, and that came up to like 0.5. So you can see a difference here of 350 times cleaner after you've done the warm perfluoride rinse. That's for PFOA. For total PFAS, we got similar concentrations. Actually, the triple rinse didn't even show a reduction. In this case, there was a lot of 6,2 FTS that was not rinsed out with the water. So we actually got quite a bit of that in the triple rinse. So water running through that fire truck before and after water rinse was about the same in total PFAS. However, when you do the proper warm cleaning with the attrition and turbulence and the perfluoride agent, you get substantially less left over and coming out. One other good question is, what does it mean for PFAS release to the environment and the firefighters? So you have a truck here, let's say it has 420 gallons in the foam tank, and you go out to a fire, you empty the foam tank and you spray until there's no more left. How much PFAS will you have shut out through the cannons? Before any type of clean out, each event, it could be as much as 95 kilograms of PFAS. Of course, that's now completely unacceptable. If we do the water rinse, you will still be spraying about 1 gram, and that assumes that you got all the AFFF liquid phase out, which is still hard. So this is kind of optimistic, but you're still spraying 1 gram of PFAS out. If you do the perfluoride rinse and get most of the stuff off of the surfaces, you're spraying something close to 5 milligrams. So 370 times less PFAS is released to the environment if you do a proper perfluoride treatment instead of just using cold water.
Hey, Gorm, what are some of the compatibility issues with the AFFF and new fluorine-free foams?
Yeah, we definitely have an uncertainty there. Um, the the one thing is, you see the old AFFF here. This is one truck. Sometimes it's not as sticky as here, and this is the new foam we showed in the beginning. Um, we have to make sure of two things. One is that the foam is going to be effective for pushing out or putting out a fire, right? That is actually going to, with the right sweeping and all that, it's going to stop a petroleum fire within the allowed amount of time, so it doesn't put people or anybody at risk. That's one. The other one is, of course, we don't want to have a lot of PFAS in what's being sprayed. The new mil spec says 1 microgram per liter maximum PFAS in the new foams, and that's in the foam concentrate. So that's 1 microgram per liter that you have to make the foam that clean of PFAS. It doesn't make any sense then to put it in a tank that's got many grams of PFAS left, right? Because now you don't have a fluorine-free foam anymore. So compatibility-wise, there is risk that and I will show you here from a report someone else wrote. It's the FAA wrote this. And they basically took different foam types, old and new, and mixed them. And their conclusions were that while in most of cases you can mix foams and it still sprays okay, but in some conditions they didn't. In some instances, mixing the new foam with just a little bit of the old stuff, it didn't perform as well. So you could say it would have taken longer to put out a fire, would have put people at risk. And it also says here in the conclusions of this report, you have to test the two foams that you're potentially getting mixed up if you're doing it, and you got to test the efficiency before you do it. And that's practically impossible for us. A lot of times we come out to an airport, they have 10 vehicles, they don't all have the same AFFF, and often the history is not super clear, so we don't really have great information on what's in the trucks. We know what the new foam is, so nobody has actually done real testing of these situations, and it's not realistic for us to do it when we have trucks moving in and out of our treatment facility. I would probably ask you, David, the next question about the waste. We brag about how good we are at cleaning out, but could you give us more detail about what waste we're generating and what we might be able to do about it?
Yeah, there are wastes that do get generated through one of these projects, and tried to capture them here. The first thing we do before we clean out the vehicle or the system is we remove the AFFF concentrate from the system. And we also perform a first potable water rinse. And both of those two streams need to be disposed off site. We're not treating them, they're too high in PFAS concentration. However, with one of the jobs that we're working on right now at a major airport, we are looking at treating that first water rinse. So depending on those results, we may be able to do that in the future. But for now, those two streams are disposed off site. That first water rinse, by the way, we do sample it, and that becomes our baseline for total PFAS that we measure against as we're cleaning out the system, and then of course doing our final sample on the final rinse. Then we are treating rinsate, so we do store that rinsate until we've sampled it and confirmed that we are at a level where we can discharge on site, and have been able to do that so far. And that is our intention, is to be able to do that. There is a sludge, as we mentioned, the PFAS perfluoride flock material that does need to be disposed off-site. That's a solid waste, but it's a very small amount. There is spent carbon, liquid carbon, that we use to polish the water before it's discharged, and that needs to be disposed of. And that's typically picked up by the carbon vendor, and then they take care of that. That's not something that we're directly involved in. And then, of course, you've got your personal protective equipment, spent bag filters, and other materials that need to be packaged and shipped off site for disposal. And finally, the municipal trash. any type of municipal trash, paper, some wood, perhaps some plastic sheeting, that type of stuff needs to be disposed of as well. So that's the waste streams that are generated that do require disposal and treatment.
You mentioned PPE. Is there anything special in the PPE you have to wear to be able to do one of these cleanouts? Are we in moon
Tyvek suits,
or no?
gloves, could be a respirator.
Yeah.
With the filters, could
Yeah.
be glasses,
Yeah.
shield type things. Yeah, the basic stuff for PPE.
Yeah, you have to be a little more aware of aerosols, a lot more aware of aerosols, typically when you're treating PFAS, right? Because PFAS wants to be in the air-water interface. So little droplets, are more critical with PFAS than other contaminants. So yeah.
And our staff are using, pressure washing or any type of aggressive scrubbing that would create an aerosol. Yeah, you're right. Exactly right.
Cool. What do you do with the waste? Where does it go?
So we have some options here that we're aware of. We by no means endorse any of these. We don't believe one's better than another. These are just the different options we're seeing out in the marketplace. So far, the work that we've been doing, our customers, more and more, they're asking us to help them manage waste disposal, but they typically choose the solidification and landfilling of the rinsate and solid material. But high temperature incineration has been used, deep well injection mostly in the Gulf states, we've seen that being used. And then these supercritical water oxidation destruction technologies, or SCWO, the three of them listed here, just the three that we're aware of. There may be others, but these are the different options that we've seen out in the marketplace that people are either using or very studying to try to use in the future.
Mm-hmm. Very good.
So we could talk a little bit about the cost to perform clean out and transition. And Gorm, you could talk a little bit about the concept of buying new, and then I can touch on cleaning existing.
Yeah, and I think that the easiest way to talk about cost is not so much to explain how cheap we are and how cost effective we are. You can never say cheap. It's from the client's perspective. What are my options? Let's say I'm an airport. I have 10 ARF vehicles, and FAA says I've got to be fluorine free in a year. What are my options? So on the left, you see if you're able to afford it, if you buy 10 new ARF vehicles and then get rid of the 10 old ones you have, that's that option. There's somewhere close to $1.5 million each, and they have delivery times, whether you get them from Oshkosh or Rostenbauer. And by the way, we don't recommend any of these names. We just use them because that's used in the industry, right? But even buying 10 of those, they don't have them in stock. It's like buying a certain Toyota has not been made yet and is not on the ship yet from Japan, right? So you can't just go out and buy 10 new ARF trucks, even if you had 15 million, and have them delivered in a month or two. It takes years to get that many vehicles. Maybe they have 2 or 3 available, and every 3 months you get one more as it is being produced. So it's the money, it's the time, and it's then the transition one vehicle at a time, where you have basically different foams at your airport. You got to separate what's in which truck to make sure they're effective if they were ever to be used. On top of that, in the buy new scenario, you still have 12 old contaminated trucks with PFAS in them. What do you do about that? It's getting more and more difficult to get rid of them because the manufacturers will never take them back. They won't even touch the foam you put in them. So they will not take a used truck that had AFFF in it back. So that's going to be a problem. You can't just send them to South America ethically without cleaning them out first, for instance. So that's the $15 million solution, David, and maybe you can.
Hey, Gorm, could I add just one thing to that? You just made me think of one of our customers, a major airport, U.S. international airport, has asked us to consider, for them, they're leasing 3 or 4 trucks that they have on site to help them maintain their index while we're cleaning out about a dozen of their trucks. And they've asked us to consider cleaning out those leased or rented trucks when they are ready to send them back to whoever they're leasing them from. And so that I see as a potential of a growing area here, is to help folks with those type situations as well.
Yeah, if you're one of those people who buy old fire vehicles really cheap, right, and then lease them out, yeah, you better make sure they're cleaned out as well properly. So it must be liability with going along with not cleaning them, and then they go to an airport and get used with the new foams, and then you might have issues either putting out a fire or exposing firefighters. Yeah.
But on the clean existing scenario, I can touch on that. So that's what the option that we're providing, right, is to clean the existing apparatus so that you have a clean system and at a fraction of the cost. And what we're showing is a range of the 550 to 700,000. And what that means is on the low end of that scale, that's economies of scale where we're cleaning more than a couple of vehicles. Like most of the airports we're working on, they have upwards of 8 to 12 vehicles. And when we're able to clean out that many vehicles at once, we move our equipment to the site, it stays there, we don't move it, and the trucks just come to us. That's when we're able to pass on that savings from moving equipment around, and that results in a lower price point per vehicle, on the order of, in this case, 10 ARFF vehicles, 55,000 per vehicle, in some cases a little bit less than that. And then on the high end of that scale, that's based on just doing 1 or 2 truck cleanouts, rather than a bunch of them. And so there's not the same economies of scale. And we are, requiring about 2 to 3 months of clean out to treat about 10 trucks, clean them out. And we believe this is a better way to manage liability. So you're cleaning out all components of the truck that have been impacted by AFFF. And we're not focusing on areas that have not been impacted by AFFF, only those areas in the trucks that have been impacted. And then we're also able to clean the rinsate so it can be discharged on site, which we believe is a better way to manage liability in the long term.
All right, I'm just going to repeat a couple of things you said to address 2 of the questions that have come in. Yes, this range is for 10 vehicles, right? So to get the rough cost per vehicle, you got to divide this by 10. So $55,000 to $70,000 US per vehicle. That was another question. Is this US dollars?
Good.
Yeah, you confirm. Okay. Great. I think it's time for us to dip into more of the questions, and I'll just leave our little contact information up here while we do it. And by the way, this is Steve Pistol. We mentioned him already, but he's one of our lead guys and responsible for the cleanouts. I will look at the questions now, David. Randy asked essentially, how much space do we need to clean out a truck? Does it have to be inside? Could it be done outside?
We prefer to be inside just to protect our staff and people from the elements. And we need at least 1 bay inside a firehouse for our equipment, and then 1 bay for the actual vehicle. So 2 bays in a firehouse is what's required to clean out these systems. And also we need space for depending on how many vehicles and how much rinsate's generated, we need space for the storage tank. Some cases it's a 21,000 gallon Baker tank, which is a good sized piece of equipment, or it could be smaller totes or even smaller tanks. But those 3 things: 2 bays inside a firehouse to protect staff and working outside of the elements, and then the storage tank outside the bays is required. Yeah.
Great. There's Troy had a comment saying there's another fluorine-free foam available as an AFFF alternative called Microblaze out. It's not something I've heard. I don't
Haven't
know
heard
if
of
we
it.
got a mil spec approval yet. There's a lot of foams, right? And there's a lot of people making foams and trying to get them approved. I cannot say whether that one has been approved. If it has, it's skipped my attention.
And what you do is you go to the QPL, the Qualified Products List site, and look and see. That's where the FAA is identifying which foams have been approved by, that meet the mil spec.
Yeah. Yeah.
And I can provide a link to that if somebody needs it.
Yeah. That is good. Got a question whether the perfluoride process works on metal surfaces. That's a yes for sure, but then also on concrete. And I would say we do not typically use the perfluoride for rinsing concrete because concrete is so porous. And lucky for us, there's typically no concrete inside fire vehicles or fire suppression systems. They're typically metal surfaces or fiberglass, which is the worst of the non-metal surfaces because it also has some porosity, or polypropylene or stuff like that. That's much easier to clean. So we've got great results with all those surfaces except for fiberglass. Whenever we see an old fiberglass foam tank with cracks and repairs and resin scars and things, we go, uh-oh, this is one's going to get be more difficult to clean out than a clean stainless steel or plastic tank. There's an anonymous, I think this is the rebound question, that an anonymous question: did you test the rinse after cleaning for 1 year? Of course we cannot do that, right? We have to look at this from our client's perspective, not really from an academic perspective. You've got a vehicle out of service for about a week, maybe 2 weeks to bring it to wherever we're doing it. It takes about 5 days to do the clean out. Then it's got to go back in service. Or if it doesn't, you can't land any major airplanes on the runway that this piece of equipment is servicing, right? So it goes out of our cleaning facility, races right back to where it's going to be in use, and new foam is put in, and it may or may not be used for training in between. We just don't have the luxury of reserving a vehicle to sit for a year and then do the rebound sampling. It's just not practical.
Can I add to that?
Yeah.
So we did a rebound study with one of the first projects we did in an airport, but it was a very short one. It was only 4 days, I believe. And that didn't show any rebound. But, to address the question, we haven't done that long, and I'm not aware of anybody that's done one that long, a year, but I am aware of a couple of airports that are considering at least doing some rebound studies after one airport used water alone for cleaning out their systems, and another airport's using the perfluoride process to clean out theirs. And I've heard talk about the possibility of doing a rebound study 3, 6, maybe 12 months after clean out to compare the two. Whether that happens or not, I'm not certain, but I know people are talking about it. And given the fact that the people that I know that are working on it, it will likely happen. So stay tuned, for another year for that information.
And I think, from an academic standpoint, there will always be maybe a little bit of rebound. This question is it measurable? Will it actually show up if you do PFAS analysis of the rinse water now and then in another month and then 12 months? You will have variability. Even if we take 3 samples today, they showed 3 different PFAS concentrations, right? So you got to be a little careful. But we are cleaning, and I liken it to a dishwasher. If your dishwasher doesn't have hot water or a heater and that's broken, and you don't put any soap in, you're rinsing with cold water and you're getting really dirty dishes coming out. And you can assume if you did it again that the water would still be dirty, and could be similar to rebound. But if your dishwasher is running nice and hot and with the proper soap, the dishes come out super clean. And then if you put water in, that water is not going to pick up much dirt from it at all. So So yes, we might get a little bit of variability in the analysis of the PFAS in the final rinse water, but it's going to be minuscule compared to if you just cleaned it with cold water. On the cost, did your cost include disposal of the waste? And if it didn't, how much roughly is it to get rid of the nasties from a clean out?
No, it did not include waste disposal. And that has typically been something that our companies manage themselves with our input, but we are being asked more frequently to help them manage that. It would depend on a lot of variables. I don't have a cost figure off the top of my head that, but I could talk with somebody about it offline to get into more detail about it, but I don't have those numbers easily, readily available.
Okay, but it's not an astronomical number we're
No.
hiding, right? When we're saying this, it's
No,
talking thousands of dollars, not hundreds of thousands of dollars for the waste.
correct.
Yeah, okay. Otherwise, I don't think 189 trucks would have been cleaned out, if that joker. What's the water temp we use for the perforad?
What is it, maximum 120 degrees Fahrenheit?
Yeah, so 50 Celsius roughly. So scalding hot, it's too hot for a hot tub for sure. But the perforad oleic acid works really well at that temperature to basically dissolve AFFF residues, and the hotter it is, the more effective it is.
And by the way, we always qualify before we do that with the owner of the system that temperature is, the system can handle that temperature, right?
Yeah, yeah. I'm sorry, I'm reading some of the questions to see which ones
Yeah, there's a lot of them.
are the most relevant. There's a lot, and we'll the ones we don't address here, we'll type up answers for, and everyone can see them at the end. ARF versus engine cost comparison. I'm not quite sure.
ARF versus structural trucks,
Yeah.
maybe?
Well, yeah, it just says versus engine. Yeah.
So ARF trucks are bigger, they're more complex than a structural truck from our experience. They take a little bit longer, maybe 1 or 2 days longer to clean out, and cost slightly more, but not by much. Less than 10% more, I think, right around there.
Yeah. I had one more thing. Gonna see if I can share my screen again for probably the final question on top assay. This is something that's come up a number of times. Basically, whether we're doing top assay. For some reason, I can't. Okay, I'm sorry, I cannot get that to share right now. But essentially, we've also done in Germany top assay for 5 vehicles just to see in the final rinse compared to the first rinse if there was something else than PFAS, targeted PFAS in there, and we were able to show very low 2 to 4 micrograms per liter total top assay total PFAS in the final rinse. So that's good. David, are you still there?
I am still here. I have that slide if you want me to show it.
Yeah. I've somehow lost my controls, so that would be good.
How's that? Can you see it?
I cannot see it, but I know what it says. So essentially showing you top assay before rinsing and after rinsing, and you're supposed to be able to see some orange bars, but they're so small on this scale in micrograms per liter. As I said, they were in the 2 to 4 microgram per liter range that you can't even see them here. So essentially, you can see this reduction in the pre-rinsing total top PFAS to the post-rinsing. So in other words, these precursors that could one day turn into PFOA, PFAS, and other targeted PFAS are not present in the final rinse and in alarming concentrations. That was the main point.
And by the way, this data was generated by our partner in Europe, Cornelissen,
Yes.
that you're seeing on the screen.
Yeah. If we take one final question, David, can you please go to slide number 14?
Yeah.
I'll address one last thing, and that is, why do you just use your water concentrations in the rinse to determine how clean the fire truck is? Why, when you listen to some other people in the industry, they say you have to swab the surfaces of the inner surfaces of the truck to actually know for sure you've got the PFAS off of the surfaces. The answer to that one is, again, our client's perspective is they don't want us to cut the truck open to get to those surfaces. You know, it's really hard. Now you're taking valves and pipes apart, and now you got to have it reassembled afterwards after you did the swabbing, and now the truck's no longer approved since the last pressure test. Now they got to have them retested. It's just not practical. So what we do instead is we run this scouring fluid through everything, rather than just test one or two areas where we can access the surfaces to do this swab testing. And that to us is just a lot more reliable evidence. It's almost like you want to show you cleaned the DNAPL area. Do you take a whole lot of samples, like 1,000 samples of soil to do it? That would be great, but it costs a lot of money. But if you could run clean water through and show that it doesn't pick up anything significant, that's another line of evidence. So just based on practicality, we finish these cleanups Thursday or Friday, and the truck's got to be back in service on Monday. We just can't start breaking it apart and doing swab testing and then waiting for those results.
Apologize for not showing you the actual slide, just seeing my desktop.
That's fine. That's fine. I think
for some reason it didn't work.
Okay. Zoom is giving us a little challenge here, more than usual. But thank you, everyone, for attending. And again, those questions we didn't have time for, we will type up answers. And if you think of some more questions, you can also email them to David or myself. David's email is dfleming, DFLEMING, @thermalrs.com. And we'll add them to the list if you think of new questions. Thank you so much.
Thank you all. Bye-bye.